All right, good morning, everyone, and welcome to the May 3rd Thursday Web Forum for the Southeast Conservation Adaptation Strategy. My name is Hillary Morris. As always, I work on user support and communications for both the Southeast and the South Atlantic Conservation Blueprints, and we host this Web Forum every third Thursday of the month. It's intended as an opportunity to get input and involvement from folks like y'all to share the latest updates on the blueprint and to share exciting science in the world of landscape conservation in our region. So with that, here is our agenda for today. I'll start out by introducing our speaker, who will present for 30 to 40 minutes on our monthly topic. There'll be time for Q&A and discussion at the end, and then I'll wrap up by previewing next month's webinar and sharing some quick updates from SECAS staff. As a heads up, we are recording this web forum, as you've probably seen. That's just as an option for the one or two people who inevitably wanted to come but had a conflict. So the slides and the video will be linked from the calendar event on the South Atlantic and the SECAS websites within a couple of days. Any questions or comments before we get started? Okay, so today's presenter is Dr. Neil Ganju, who is with Woods Hole Coastal and Marine Science Center with the USGS. He's a research oceanographer, and he's going to be talking about a recently developed metric called the unvegetated vegetated ratio, or UVVR, which can help assess marsh stability. And we are actually using that UVVR data in a new indicator of stable marsh in the 2022 Southeast Blueprint, which we're working on now, a version of the blueprint that uses more consistent methods and indicators across 15 states of the Southeast. So very interested to learn a little bit more about this data. Neil, I'll go ahead and hand things over to you, and you can take it away.
All right, thank you, Hillary. Good to not see everybody, unfortunately, in person, but maybe in the future I'll make it down there. And let me just get this going. All right, so thanks again for having me, Hillary, and I'm looking forward to sharing this all with you guys. And I want to acknowledge my co-author. So Brady Kubian, who's down at the Wetland Center in Louisiana, is really the architect of the actual data behind here that you're going to see. And then Zafir and Kate are here in this office and help a lot of the validation of the metric. And then I'm going to show some interesting results across the Southeast that we worked on in collaboration with Michelle Moorman in Fish and Wildlife. And Caroline Schwab is a summer student at City College of New York who's working with us on that analysis. So most of you are probably aware of the role of salt marshes from an ecosystem services perspective as well as a natural perspective. If you think about the square kilometers of marsh in the country, it actually is equivalent of about 100 meters width of the entire tidal shoreline of the United States. So this is a huge amount of real estate and land that serves as habitat, carbon stock, coastal protection. And this plot on the top here is sort of the historical idea of how marshes are created and sustain themselves with tides and sea level rise. And the idea is that where you get marshes is dictated by the tidal elevation and the topography, so kind of entirely in a vertical context. In reality, what we see in this century as well as in the future is marsh loss that's actually a three-dimensional process. So not just vertical submergence, but also erosion from edges, loss of interior marsh due to ponding, and anthropogenic things such as ditching, which you can see in these plots here on the bottom. And ultimately, the physical forces that are responsible for that loss end up being things like sea level rise, wave erosion, and sediment deficit, so lack of sediment supply. So that last point, sediment supply, is what we're kind of going to transition into before we get to the UVVR. So a little bit of background on all that. So if you think about sediment budgets, marshes require an input of sediment to keep up with sea level rise and wave erosion at the same time. So if you were to draw a box around a marsh complex, so that's what this blue dotted line is representing, you can think of sediment inputs and outputs as a budget. So all the red here that you're seeing on the left are withdrawals in the sediment budget. So you have marshes can slump on the edges and sediment gets put in the channel, erosion of that mud flat, as well as erosion of the channel itself. In the meantime, there are deposits. So there's deposition on the marsh plain, there's deposition on the mud flats where vegetation can then reintroduce, and then there's deposition in the channels. Obviously, it's very difficult to measure each of those independently, but if you can measure sediment coming in and out of that bigger blue box, the question is, can that be a diagnostic indicator of the trajectory of the marsh? This would tell you if a marsh is on the net importing sediment, then in theory it should be stable. And if it's exporting sediment, then perhaps it's unstable. So that was the hypothesis we set out with about 10 years ago to measure sediment transport in and out of main tidal channels of marshes and see if we can diagnose their trajectory and ultimately their instability. So we did that across 8 sites across the country. We actually did a couple sites in the Gulf as well that are in a companion paper. But each one of these dots represents months to a year of sediment transport measurements made at very high temporal resolution in channels of salt marshes. And what we're showing on the y-axis is that net sediment budget that we measure with sensors. And then what we wanted was some independent metric of stability. So we decided to go with basically the fraction of vegetative cover, so kind of an open water ratio. But what we did instead was we measured that, but then took the ratio of unvegetated area to vegetated area and presented that as a non-dimensional metric. So that's what you're seeing on the y-axis, on the x-axis, sorry. And one of the reasons we chose to do it as this ratio is our most unstable site, which is out here, Blackwater National Wildlife Refuge, had a UVVR of close to 1. So that makes it kind of a handy parameter space that just goes between 0 and 1. And keep in mind that at a UVVR of 1, you're talking about an area that's half unvegetated, half vegetated. So it's 50-50 vegetation cover. But that's kind of a nice endpoint to end there at 1. So the first thing you see from this plot is every site is actually in deficit. So once you measure that sediment budget that we did and add in the sea level rise deficit, no site was bringing in enough sediment to keep up with sea level rise. Even our most sediment-rich site out here in Chesapeake Bay was still in deficit. The second thing you see, obviously, is there's somewhat of a nice relationship here where you have increasing sediment export as the UVVR goes up. And then the third thing we see is that there's a tipping point somewhere where you cross from surplus to deficit at a UVVR of about 0.1. And I'll show another study that showed one about 0.15. So we see that there's a tipping point in instability somewhere around 0.1 and 0.15, and that becomes important later, as you'll see. Just to show you what that looks like from a UVVR perspective, these are the aerial images that we use to compute the UVVR at our sites. And so in orange, what you're seeing is the vegetated plain, and in blue or black is what you're seeing is unvegetated, whether it's water, channels, or ponds. And so you can see this progression from a nicely vegetated marsh plain to one that starts degrading and exporting sediment to one that's almost half unvegetated and exporting massive quantities of sediment. So one of those companion studies from 2020 showed a tipping point at 0.15. So these are basically, we used aerial imagery across companion sites across the country to show the decadal change in UVVR relative to the UVVR at the start of that decade. So that's what you're seeing on the x-axis is the UVVR 10 years prior, and then on the y-axis is the decadal change in UVVR after 10 years. So below 0.15, there's not a lot of change, and then we see this really rapid change above 0.15. And the idea is that you're kind of at a stable state below 0.15, and then once open water expansion starts to happen, whether it's because of sea level rise, whether it's because of storms and waves, or whether it's because of sediment deficits, that instability grows exponentially. And this is actually supported from several modeling studies as well that incorporate these processes. So having said all that, once we got to this point, we thought, okay, what we really want then is a map of UVVR across the nation. So we don't have to do these 10-year studies on small footprints. We want to be able to do it everywhere and do it through time consistently. So that's where Brady set out to make this national map of the UVVR, and so we published it last year. And I think Hillary will throw some links in the chat so you can access the raw data as well as the paper, which I'll basically be describing throughout this talk, as well as a geo-narrative story map that shows all this data as well, so you can browse it yourself. So basically what we have is a Landsat-based product at 30-meter resolution that covers the entire contiguous United States. We produced data from 2014 to 2018, which is Landsat 8. So we have data for each year, and then we actually composited all 5 years to produce sort of an average condition for those 5 years, as well as the standard deviation, which we'll be talking about later. Here are just a couple snapshots showing the San Francisco Bay Area, the Chesapeake Bay region, as well as the coastal Louisiana region. And so throughout this talk, you're going to see the same color scale. with the idea being that dark green is a very low UVVR and a stable, healthy marsh. And then when you transition from this light green to white, that's past that 0.15 tipping point. And then once you see the really dark magenta colors, we're talking about a marsh pixel that is no longer really functioning as marsh. It's more open water, actually, than vegetated plain. A couple caveats. So I've spent a lot of time, as well as the rest of our team, looking at this data very closely, figuring out where it looks right and where we're not quite sure what's going on. And here's what we figured out. So one thing that we find, and this is kind of common sense, but it took us a while to figure it out. Historically, our UVVR method that you saw, for example, in the prior plot that showed the three complexes on that XY plot, those classifications of UVVR assume that if a pixel has vegetation in it, it's a vegetated marsh plain. It gets a value of 1 for vegetation, right? It's a binary choice of 0 and 1. When you're using a satellite or an aerial image over a pixel, you're now integrating the information within that pixel. So for example, this is a marsh right outside Charleston, and that 30 by 30 meter pixel that covers this marsh shows a very high UVVR, even though it's technically a fully vegetated plain. When you go down and take a photo of the marsh plain, though, what you see is that it's got a lot of bare sediment, and so the satellite, which is up there looking down, the signal that it gets back is seeing all of that bare sediment. And so it spots this as a very high UVVR marsh and therefore vulnerable. And there are several marshes in South Carolina and Georgia that fall into this category where the eye with aerial image would say, like you can see on panel A, says, oh, this is a vegetated plain. But the satellite says, well, it's actually pretty sparsely vegetated. All of this is to say that when you are looking at these data, you want to be careful that you're looking at a region and not trying to, you wouldn't want to compare, let's say, for example, a northeast marsh, a high latitude marsh with a 3 meter tide range to one that's in South Carolina. So you just want to exercise caution when comparing areas. The second thing is I'm going to present a couple metrics in a minute here that aggregate the UVVR over domains. And what you want to note is that when you're looking at the UVVR at this 30 meter resolution, if you have large expanses of open water like we have here, I think this is Terrebonne or this is Barataria Bay in Louisiana, when you have these large expanses of open water, keep in mind there are no data there. So if you aggregate over those, you're going to have null values that don't exist. If you want to include those in the calculation and make them unvegetated, then you'll get a slightly different UVVR. And so what we call those is UVVR low, which is where we don't consider open water, only what's the vegetated plain and the instabilities within it that are smaller than 30 meters. And then UVVR high, which is aggregating any water feature that's within there that might be larger than 30 meters. And I'll show you what that looks like in a second here. So just a couple, one of the things we did in our paper, which will be in the chat, that just came out a month ago on estuaries and coasts, and this is a management applications paper, so really geared towards users who want to use these data to track wetland stability. We basically selected the largest estuaries around the country and did an inventory, not of just the total area that the wetlands inventory would give you, but then what you get for vegetated area when you apply the UVVR. And then we sum that up to give you a percent of the nation's total. So a couple of the areas that pop out within the South Atlantic, for example, Ablemarle and Pamlico on the North Carolina, Virginia coast, very intact, very low UVVR, both from the UVVR low and high perspective. So not a lot of fragmentation, very intact marsh plains, 5% of the nation's total vegetated area, which is obviously a big number. And then conversely, St. Helena Sound in South Carolina, very high UVVRs, 0.6, which is well past the tipping point, but still accounting for almost 2% of the nation's wetland area. So I want to show you what those two look like, for example. So here's Swan Quarter up in North Carolina. And so this is what that UVVR map from the story map looks like if you want to browse it later on. And when we zoom in on this box, you can see here the UVVR. So green is really good, pink is that above 2. And then there's the aerial imagery. So this really nicely captures this open water ponding area down in here, a little bit of the ponding here. And again, UVVR well below 0.1. So this is what we would consider pretty stable marsh areas, although there are some areas of concern, especially down here in the south part. Firstly, South Carolina, St. Helena Sound, we have these large expanses of sparsely vegetated marsh, and the UVVR picks this up. You can see just kind of really wide expanses of poorly vegetated marsh. You can see a lot of fragmentation in these areas. You have nice intact vegetation here, but throughout everywhere else, very degraded marsh plains. And I actually had Michelle send me some photos of some marshes in Mackay Island, for example, and we see the same thing where photos of the marsh show very sparse vegetation with mud in between, and that's giving us a very high UVVR for these sparsely vegetated marshes. So the other thing we can do, obviously, is aggregate across states, and this would be obviously very useful for SECAS and around the nation to get an inventory of how much wetland area is contained within each state. So obviously Louisiana, with the expansive coastal marshes, is number one, Florida number two, and definitely the winner for integrity. And this is largely due to the fact that mangroves have very dense canopies, so the UVVR is going to be very low because you have very comprehensive vegetation. So that's pretty cool. And obviously, if you take all the states of SECAS together, we're talking more than 80% of the nation's vegetated wetlands, coastal wetlands. But now that I've kind of just given a very broad brushstroke of the data, and again, you can navigate those all in the viewer that's in the chat, as well as the papers, I wanted to show a few of the applications that we've thought of how to use this data, and then obviously looking forward to seeing how the different state and federal agencies use the data. So the first really nice use is just looking at tidal wetland change across sites and across regions with a uniform data set that you don't have to go out and generate yourself. So speaking of mangroves again, the first example I wanted to show is from the Southern Everglades. So this is Flamingo in Everglades National Park, close to my heart because I grew up in Miami going to Flamingo and paddling amongst the crocodiles and alligators quite a bit. So this is a very special place to me. And just recently, this paper came out from Lagomasino et al. Showing with very high resolution in several data streams the mangrove dieback due to Hurricane Irma. And this was a combination of several data streams. So they had LiDAR, aerial imagery, as well as Landsat with a 3-month interval pre and post. With our data, so this is annual data from Landsat, we can see the exact same dieback. And what's nice is that this is now obviously national for every year. So if there are areas where you don't have the ability to go out and map them, the data have already been collected. And so what we see is 2014 and 2016, this is actually the vegetation fraction, so not the UVVR, but the derived product. You can see Flamingo is nicely vegetated, 2014, 2016, and then Irma happened in 2017, and then here in 2018, we see large areas of dieback, almost 50%, from 100% down to 50% vegetated, and then almost near dieback in this part near Flamingo. And you can see that in Lagomasino's data also. So what's really nice is that these data are available. They can be used across all sites around the nation where you might have had loss due to storms. On the positive side, you can use these data to track restoration. So here are a couple projects down near Lake Pontchartrain. These are mitigation efforts by the Corps, Bayou, Chevy, and Turtle Bayou. And these areas are basically kind of levied off and graded and then allowed to revegetate. And so from 2016 to 2018, in both of these bayous, we see return of vegetation, almost a 40% increase in 3 years. And again, the nice part of having this robust national data set is that given all the restoration that's going on through NIFWIF, through Park Service, through all sorts of agencies, we can have one data set that's available to track these in the same manner. So it kind of facilitates uniform tracking of project success. Okay. The second application I wanted to show is identifying vulnerable areas. And I think this is one of the ways that SECAS will be using the data in the conservation blueprint. So I'm going to walk through it a little bit, just show you what that looks like. So remember, we have this data for every year for 5 years, 2014 to 2018. And in each year, we have a value of vegetation fraction and UVVR in each pixel. So when I first looked at these data, I was kind of concerned about how the data changed from year to year, whether those are artifacts or real data. And then I realized that we can actually use that to our advantage. So the idea is that if you have a wetland pixel that has a UVVR value that's low, meaning healthy, and it stays at that value all 5 years, we have good certainty that that's a stable wetland pixel. If we have a value that's above a certain threshold, that 0.15 value, and it's moving around a lot, we have a little less certainty about stability now. And so the idea is to use that fluctuation as an indicator of both stability and certainty. So this is just an example from Mackay Island National Wildlife Refuge on the North Carolina-Virginia border. So the aerial image on the left and then the 5-year UVVR on the right. So if you take each one of those pixels within that domain I just showed you and you plot the 5-year average UVVR, which is what's on the x-axis, and then the standard deviation across those 5 years on the y-axis, you get this really noisy plot. And what we do is we use this 0.15 threshold to break it up into 4 quadrants. And you're going to see a few more quadrant type things, so you'll have to get used to this way of thinking. So down here in this left quadrant, this bottom left, this is all the values that are below that, all the pixels that are below that 0.15 threshold, so they're good, they're in good shape, and the value's not changing much. So these are wetlands where we're pretty sure they're stable, there's not a lot of change. Conversely, out here in class 2, you don't see much of these. These are ones that are below that stability threshold, but might have 1 or 2 years with a big fluctuation. Where we have seen that, it's been areas that are subject to overwash from Barrier Island, where you might have vegetation for 4 years, and then there's one big overwash event that pushes sand over the pixel, and now you're seeing a UVVR that's very high. Class 3 is up here, so these are areas above that threshold with lots of fluctuations. That might be due to water levels, perhaps a controlled burn every other year. And then lastly, the other one that we're most concerned with are the ones that are above that threshold, so they're unstable, but they're also staying up there pretty consistently. So we're pretty certain that they're unstable. So what's nice is you can basically classify these pixels and then map it. And so this is what you get. And so that dark pink, that's that class 4, the unstable with very low uncertainty. They're very consistently above that threshold. We would consider those areas at risk. So without having to look just at the UVVR map, you can look at this map now and see very clearly that there's this region up in the northern part of the National Wildlife Refuge that's very much at risk. There's a lot of vulnerability there. Conversely, you have this dark green area. This is the stable wetlands, low uncertainty. These are the ones that don't require much intervention. They're pretty stable. They should be conserved. You should be looking at migration up to this, this landward edge here, whether that's agriculture or residential areas or forest. These are areas that might be prime for acquisition and or protection. And then the other interesting category is this light pink. So these are the ones with a high UVVR, but big fluctuations. And the method actually picks these out as impoundments. These are actually managed impoundments where water is brought in throughout the year. So you can see those showing up in this high UVVR, high fluctuation area. The third application I want to show is a decision matrix that brings in elevation as an additional data stream. We haven't done this yet throughout the country. We have done it in the Chesapeake where we have very good LiDAR elevation, and that's what I'd like to show you now. So you can imagine a very simple, again, 4-box matrix like I just showed, where you think about marsh parcels or pixels that have high elevation and low UVVR. So these are both vertically stable relative to sea level rise, and they're laterally intact. These would be parcels you'd like to protect or acquire if a possibility, right? They're in good shape, they're good habitat, they have good ecosystem value. So that's out here in this top left. Conversely, you have low elevation marshes, so these are low relative to sea level, and they're high UVVR, so they're degrading laterally at the same time. So these are ones where maybe it's not worth the investment because it'd just be too expensive and it might be best to lose these unless they are valuable from a habitat perspective or possibly a coastal protection perspective. And then you have these other 2 boxes that are kind of bipolar where you've got a low UVVR, low elevation. These might be ones you'd want to monitor, and then high elevation, high UVVR. These might be good restoration options because you've already got the elevation capital. Might be worth the effort to increase the vegetative cover through restoration. So here's what this looks like. You can map this on your landscape using LiDAR data for the elevation and the Landsat UVVR for the UVVR, and the map of Chesapeake's on the bottom left, and this is just an inset just east of Blackwater National Wildlife Refuge. So here are those 4 colors mapped onto the landscape. So here's the do nothing, the abandoned box. This is this marsh that's up here in the top. It's within a pond. It's low elevation. It's falling apart. It's not really adjacent to, residential area or any kind of development, so it's not offering any coastal protection. It could be good water bird habitat, but barring all of that, this would be one you might let go because it's not worth the effort. Here's a monitor parcel, low elevation, but intact. You would want to maybe keep an eye on these ponds to make sure they're not expanding. A restoration option. This is the light brown little egg-shaped island in here. This is basically a high elevation marsh parcel, but it's also kind of having some lateral deterioration within it. This might be one where you want to look at draining off some of the standing water or possibly doing some planting to restore the vegetated plain. And then lastly, the protect option. So high elevation, low UVVR. It's right adjacent to a forest. This would be a good candidate for protecting the upland for future marsh migration. All right, and then the last application I want to show is bringing in vertical trend data with the UVVR across the southeast. So this is the work with Michelle and Caroline I talked about. So in case you're not familiar with the SET network this is across the South Atlantic LCC. These are data that Michelle and others published in the Fish and Wildlife Report. And basically the SET, if you're not familiar with it, is a point measurement at a few points across the marsh that tracks the elevation change, both the total elevation as well as the accretion. And then these are all the sites where they had those along the coast, differentiated by vegetation type. So there's 18 sites in this analysis. The SLR along the East Coast, roughly between 2 to 5 millimeters per year. We're going to show a nominal value of 3 millimeters per year on the next plot, just so you know. And then elevation changes at these sites were anywhere from -10 to 7 millimeters per year. So I want to give some full disclosure. I have been very critical of SETs in the past, both in print as well as in cartoons. This is a cartoon I've shown a couple times. The implication here in this cartoon is that an SET is giving you just a point on a marsh plain, and you could have lateral deterioration happening all around you, and the SET itself could be on this really robust piece of marsh plain that continues to accrete in response to sea level rise, while the rest of the marsh complex is eroding due to storms and waves. And so the idea is this poor SET operator is stranded on the island making his SET measurements. I'm happy to say that this is not what occurs in our data that we're looking at here. So the implication here is that the marsh is vertically keeping up at the SET location, but it's laterally falling apart. So when we compare all of this data between the SETs, which is on the y-axis, and the UVVR on the x-axis, that cartoon would be out here in the top right. So these are areas that are keeping up with sea level rise, but are falling apart laterally. And as you can see, there are no data in this quadrant. So the cartoon is likely false, and I might stop showing it now, or I might keep showing it in order to make the point of this plot. The areas where the SETs and the UVVR agree would be the top left here. So these are areas where the SET is showing that the marsh is keeping up with sea level at those points, and the UVVR is very low. So it's both vertically and laterally resilient. And then out here on the right, these are areas where the SET is not keeping up with sea level rise, this 3 millimeters per year, and the UVVR is above that 0.15 threshold. So these are both vertically and laterally vulnerable. And you can see these points out here. So there's really only a couple outliers. This is St. Mark's, Roanoke, and the Pocosin sites. And you'll see that these outliers in black, St. Mark's actually, our analysis right now is including all of the upland forest, which is pretty sizable. So the UVVR might be biased a little low in the good sense. So that point will probably move out to the right once we only account for the actual coastal wetland parts. And then Roanoke and the Pocosins, those are pretty forest canopied sites. So obviously the UVVR, being a satellite imagery derived product, is not good in areas where you expect a dense forest canopy. So those are probably explaining those outliers. So now what I want to show you are a couple of the data points from Waccamaw and Harris Neck to show you why these data agree where they do. So Waccamaw, National Wildlife Refuge in South Carolina. So the SET there is showing 7 millimeters per year, so well above sea level rise. And the UVVR data here in green is nearly zero, so completely vegetated. And this is just showing you that the NWI classification of wetlands and forest and where the SET is. So this is just a classic example of a very robust marsh plain, a lot of sediment input. It's trapping sediment, it's building its own organic material and burying it, and it's intact both vertically and laterally. So that's why these two metrics agree here. Then you look at Harris Neck, a very different story. So you can see here the SET trend is showing 1 millimeter per year, not keeping up with sea level. The UVVR across Harris Neck is about 1, so it's half vegetated, half unvegetated. You can see the degradation of the marsh plain from the aerial image and then as well as in the UVVR. And the idea again here is that if you have a marsh plain that's degraded, it can't trap sediment, it can't build vertically or maintain its lateral integrity. So this is really kind of highlighting that three-dimensional perspective of marsh resilience and why you need both the vertical and lateral stability to build a healthy marsh. So just to recap everything, what we aimed to do when we started this project was build objective metrics for the entire nation that integrate spatial patterns. So aren't just point measurements, aren't transects, they are across entire spatial scales. So the UVVR kind of satisfies that for us. It's formalized, it's standardized, even with its caveats and its obvious flaws, it's still something that you can use across sites to compare things. It's customizable on multiple scales. I didn't show the other version we do that's based on very high resolution imagery. It's obviously more effort, but the concept still applies and we use that as well. And then having it grounded in the field work we've done and by other models and analyses that are done really lends a lot of credence to it. And we think it's really one of the foundational products to help us guide management restoration moving into the future where this is going to be a high priority for all of us, maintaining healthy marshes and figuring out where to direct our resources in the most cost-effective way. And then what we're moving forward to is extending the UVVR with Landsat back to 85, so we'll have kind of a long time series, and then moving it forward with higher resolution satellites with better bands and better data, and optimizing this across projects as well as agencies with Fish and Wildlife and Park Service. And then obviously as USGS being a science agency, we have a lot of science to do with these data. We're looking forward to that. So I thank you for your attention and glad to take any questions.
Thank you so much. Awesome presentation. Feel free to drop questions into the chat. You can go up to the reactions bar on Teams and raise your hand, or just pop yourself off mute and jump right in. Doug Newcomb, I see that you have your hand up. Do you want to ask a question?
Certainly. Glad to hear that you're going back to the earlier versions of Landsat. Have you considered using your method to correlate with the relative sea level rise levels for the 2000, 2010, 2020 and intersect that with the elevations?
Yeah, that's a great question. You basically, there's a slide I didn't show, which is the lifespan method. And I kind of shied away from it because it's a little more involved and we're only doing it in select places. But basically, the lifespan method is doing exactly what you're saying. You take the UVVR as your kind of inventory of what marsh plain is available. You take the elevation to compute how much available capital you have in that marsh plain. And then you apply the sea level rise scenario, the NOAA downscaled scenarios, to then look at a time scale of how much time you have left before the marsh has to start cannibalizing itself in order to keep up with sea level. So it's almost exactly what you're saying. You use the SLR predictions to figure out a time scale of life for the marsh. And we've shown that in a couple papers, and we're doing it right now with Fish and Wildlife to look at restoration investments along the East Coast. But it's almost exactly addresses your question. And I'm glad to show you that offline sometime.
Well, if you're interested, I've done that analysis at both the 3-meter and 5-foot resolution elevations for the coast of North Carolina for 2000 to 2010 under all of the relative sea level rise analyses. So I'd be more than happy to share that data with you.
Yeah, that sounds great.
I'm looking at the planet data from 2020 just to try to get a fine scale of what's happening at that scale, but it sounds like what you're doing might be more applicable nationwide.
Yeah, our hope is to do the lifespan with this national product. The difficulty becomes getting good elevation data nationally that's of the same quality, where you might not have the best LiDAR or even, a DEM that's corrected for vegetation effects. That calculation won't be as good. So that's why we're kind of proceeding very slowly with that.
Thanks for the question, Doug. If you want to put your contact information in the chat, maybe then y'all can connect offline. Let's see. I see one other hand up. Jacqueline Wooler, do you want to go next?
Sure, thanks. Hi, Neil. This is Jacqueline in EPA Region 2. I missed the first part of your presentation, so sorry if you mentioned this, but I'm curious what, if any, work for this is going on in Puerto Rico. We have Puerto Rico as part of our region in EPA Region 2, and we are working on a couple of different efforts to just sort of strengthen their wetland programs and support restoration efforts. And so I'm just curious if Puerto Rico, if there's data available, if there's any work that's been done related to what you've been talking about. So I was especially interested when you're talking about the mangrove loss in South Florida, because Puerto Rico, of course, has many of the same problems as South Florida with storms and similar habitats and things like that.
Yeah, so unfortunately, we've only been working in the contiguous U.S. I have been really interested in trying to get something going in Puerto Rico because our coastal hazards program here has done quite a bit with the University of Puerto Rico, Mayaguez, on shoreline change. And I think it would be a no-brainer for us to do some of these mangrove canopy type estimates with historical satellites as well as aerial imagery. So I would definitely be really interested in pursuing that. That's kind of a programmatic pivot that I'd have to make, but I'm very interested in it. So if you have some ideas of how to attack that, I'd be glad to talk about it.
Yeah, one of the things we're going to be working on this summer is getting together a Caribbean wetlands work group with, academia, DNER and DPNR, the respective agencies in PR or Puerto Rico and USVI, and just a lot of different scientists and regulatory people together for this work group. And I know this is definitely going to be a topic of interest, from all different angles, mangrove restoration, prioritizing areas. They're pretty stretched thin for resources, so definitely prioritizing and, using some kind of tool like this could be very beneficial. And we're always looking to help provide, EPA's role is to help provide technical assistance. And this is something that definitely would be of interest. And as we get that going, if there is a chance for you to join in a meeting once or twice, or, just to talk to different people to get ideas of how to possibly get this going down there, I'd be happy to share more information as we get that going over the summer.
That sounds great. Yeah, please keep me in the loop. We have lots of resources that we can bring to bear on that, both from the remote sensing as well as the field observations. So yeah, keep me in the loop.
Okay, great. Thank you. And
Thank
great
you.
Presentation.
Thanks.
Jacqueline, honestly, I'd love to stay in the loop on that as well. I mentioned in the chat, SECAS, we're expanding this new consistent blueprint approach to the U.S. Caribbean next year, both Puerto Rico and the U.S. Virgin Islands. So we would also be really invested in getting this data expanded and love to be part of that conversation and see if we could help with that.
Yeah, certainly. Thank you.
Thanks. Chris Cooper, do you want to go next? And then we will go to Dylan.
Sure. Hi there, everybody. Nice to meet you, Neil.
Hello.
Presentation. My name's Stephen Cooper. I'm actually in here from the Southeast Coast Network of Inventory and Monitoring for National Park Service. And obviously we have coastal parks with salt marsh resources up and down the eastern seaboard and in the Georgia Bight. One of the I've been reading up on a lot of your stuff and talking to some people that you've worked with, like Nathan Bush with Fish and Wildlife Service. And we are trying to put together a monitoring protocol based on satellite imagery to get that spatial picture, along with some colleagues of ours up at our Northern Coastal Barrier Network that you may have already spoken to as well.
Yeah.
One of the issues that we run into, though, with like something like the Landsat product is the resolution issue, because obviously a lot of our parks are just such some smaller spaces that a 30-meter pixel isn't going to tell me a whole lot about what's happening in their management unit. And so essentially, I'd love to reach out to you personally at some point and talk a little more about the high resolution stuff that you're working on. See how we can work what we're doing into what you've done with Nathan Bush, and really we'd just like to be a part of what's moving forward with all this. That'd be great.
Yeah, so the high resolution version, it's a little more work, but it gives you what I think is probably a better handle on the management scale. So in that version, what we do is we use NAIP, the National Agricultural Imagery Program data, along with the best LiDAR data we can find. And we use that to do kind of a mixed classification, both, machine learning versus a human, picking the classes. It's a mix of those two to select what's vegetated and unvegetated. And so that's, anything from a 60 centimeter to 1 meter resolution. So it captures, everything of interest. And then we aggregate those over marsh parcels that are defined by the topography gradients. So it'll, pick out parcels that are bounded by levees or ponds or whatever. And then we compute the metrics over those parcels. And so that's what we've done across the Northeast, and that's what we've shown Nathan. I think the furthest south we've gone is into North Carolina. As part of our Chesapeake Bay work, we kind of kept moving. We couldn't stop right at the Virginia line. We had to just keep going. So we went into Mackay and we stopped there. But we can definitely show you how that's done. It's all documented online with the metadata and the workflows. And there's some nuances that take a little work. But yeah, we'd be glad to walk you through that if you guys are interested.
Oh, for sure. That would be great. I'll reach out to you in email following the presentation. Thank you.
Awesome. Yep.
You've got his contact information, Stephen?
I do, yes.
Okay, beautiful. And then Dylan, your question next, please.
Alrighty, thanks for the great presentation, Neil. I was wondering a little bit more about, I saw the links you put in the chat, Hillary, and I was wondering a little bit more about the Chesapeake Bay LiDAR integrated data. And like the do nothing, protect, restore, monitor, that sort of output. And I was just wondering if maybe I missed it in those links, if it's like that data is available online.
Yeah, that data is not yet available. The data is available. I mean, that's all publicly, it's all published stuff. The methodology and, suggesting this is a thing, I haven't written up yet. I'm working on that now as part of our Chesapeake Bay data analysis, which includes what I was just telling Stephen about, that kind of detailed NAIP version. We're doing that for the whole Chesapeake, and that's actually done. We're just finishing the publication steps. But the idea of merging the LiDAR with the Landsat UVVR is something, I'm going to have to put it together into one product. But, if there are applications now that you folks see in Maryland or Virginia about using that, that's certainly something we can do now. There's nothing that has to be published to make that kind of a data set. So I'm trying to think how that would actually work. I mean, we do. I guess we would have to publish the metadata for what LiDAR we pulled together to match up to the pixels. So that might be that's kind of the thing. But
okay.
I'll make it a priority. If you say it's a priority, I'll make it a priority.
All right. Yeah. Well, I mean, I'll shoot you an email and
okay.
See what we can get together. Yeah.
That'd be great. Thank you.
Thanks. Good question. Loving all this discussion. I don't see any more hands up. I might kind of selfishly insert one of mine in here with some of the time we have left. I don't know how familiar you are with the methodology that the Nature Conservancy used for their resilient coastal sites analysis, but that's another data set that we use in the blueprint to kind of get at resilience of coastal marshes to climate change and the ability of tidal complexes to migrate and all of that good stuff. And I was wondering if you could speak to a little bit just to how your approach differs from what TNC? Are you all kind of going after different aspects of this problem? Are they complementary? I'd just love to hear you speak to that a little bit.
So I haven't looked. The most recent thing I looked at that's a similar vulnerability analysis was NOAA. I saw a NOAA product that just came out that had that used the UVVR in it as a aggregated over hydrologic units. I haven't looked at the Nature Conservancy's data set. What I would say is, in my personal experience, what I have found is when we try to do, because we have tried to do very complex vulnerability analysis with 12 to 15 data layers mapped on units, I have found that those have not resonated with practitioners. What has resonated so far is like that thing that Dylan was just mentioning, that really simple elevation UVVR metric, because every one of us understands those two metrics, and we can look at a map that shows them and be like, yes, that makes sense. I think, and this is just me personally as a scientist who doesn't do management or practitioner but uses data, I would crave the simplest possible thing given the urgency of the problem. I would go for, and because what you're trying to restore to is elevation and UVVR, right? Well, everything we all want is elevation capital and ecosystem services, which largely are based on vegetative cover. You know, for many species, the habitat is tied to vegetative cover, the carbon sequestration potential is vegetative cover, and the coastal protection aspect is vegetative cover. So I think using the actual metrics that you're trying to restore to as your identifiers makes sense to me, but I can be very simple sometimes. So that's all I can say about that. I'm sorry.
That's helpful. Thanks. Yeah, sometimes simple is better. Any other questions? We can probably take another 5 minutes before I need to wrap things up.
My pleasure. Thank you, everybody.
Yeah, thanks so much. I'll pause 10 more seconds just in case someone was about to speak up. All right, I'll go ahead and move on, but we will pause again for questions at the end. So if something occurs to you in the next couple of minutes, you can jump in then. Let me just go back to sharing my screen and we'll wrap up. Sorry, let me drag the video over to my other monitor. Just wanted to tell you all what to expect for next month's web forum. It'll be the same time, same connection information as today, 10 Eastern on the 16th of June. And we'll be hearing from the science coordinator of the Atlantic Coast Joint Venture, Mo Carell, about their work to conserve coastal marsh systems. As most of you probably know, the Atlantic Coast Joint Venture is a regional partnership that collaborates to restore and sustain native bird populations and habitats throughout the Atlantic Flyway. And they've really focused on one of the most imperiled habitats in the joint venture's region, which are coastal marshes and the vulnerable birds that depend on them. So they're really leading a coordinated marsh restoration and protection effort throughout the Flyway. And they're creating a series of science products and initiatives as part of that coordinated effort. So Mo Carell is going to go over some of their regional science efforts that are underway for the flagship species of the joint venture, the salt marsh sparrow, the eastern black rail, and the American black duck. So a lot of folks on the line here interested in coastal marsh systems. I definitely encourage you to tune back in next month to learn about what the Atlantic Coast Joint Venture has underway right now. And then I want to wrap up just with one quick update from staff. We are wrapping up our round of Southeast Blueprint workshops. In fact, the last of our 16 virtual workshop series are wrapping up right now as we speak. So I'd encourage you to look for a blog in the May newsletter for the Southeast Conservation Adaptation Strategy that will really summarize the feedback that we received on the blueprint and some of the ways that we're already exploring improving the data and methods based on that input for this year's blueprint. So the 2022 Southeast Blueprint, which as I mentioned, is going to use this improved methodology and more consistent methods and indicators across 15 states of the Southeast. That final product is scheduled for release this fall in time for CAFWA. So between now and then, we'll be hard at work incorporating those improvements that I mentioned based on the feedback we received at workshops, and anything we aren't able to fix for this year, we'll be capturing as known issues in our documentation and using that to prioritize next year's updates and beyond as we continue to revise and improve the blueprint. So I always like to end on this slide, how to get more involved in SECAS. I definitely encourage you to sign up for the SECAS newsletter at secassoutheast.org. This third Thursday web forum series is promoted in that newsletter, and so that'll keep you in the loop for opportunities to get involved in the blueprint and various webinar opportunities throughout the year. Feel free to connect to your SECAS staff on the staff page, or see the partners who are participating in SECAS governance on the partners page. Or of course, we encourage you to explore the Southeast Conservation Blueprint online, and please reach out to your user support staff. We're here to help you for free to use the blueprint in your work, whether that's to inform a decision or support a grant. That's why we're here. We'd love to hear from you and help in any way that we can. So with that, I will pause again for questions. Hearing none, I'd say that's it for today. Thank you again, Neil, so much for that wonderful presentation. I appreciate everyone who tuned in and participated in that great discussion, and I hope that we will see you all next month. Have a great rest of your week.